Hi, I'm Judy Cole, the Executive Vice President and CEO of the MIT Alumni Association, and I'm delighted to welcome you to this web production of the MIT Alumni Association.
Welcome to the MIT Faculty Forum Alumni Edition. I am Jocelyn Scheirer, and I will serve as moderator. This is an interactive forum, so we encourage your questions. Please use the Google form below the live stream to ask a question or to tweet one to hashtag MIT Better World. We'll get to as many questions as we can. Our panelists are here today to share with you their research on smart fabrics and textiles, wearables, biodesign, and medical devices. Panelists, let's have you introduce yourselves and give an overview of your current research. I'm going to introduce myself first. My name is Jocelyn Scheirer, and I've been working on wearable devices, primarily wearables that sense and communicate the emotional response since the mid-90s when I was a grad student at the MIT Media Laboratory. I've been part of 3 startups that were spin-outs of the Media Lab. One I helped co-found with 2 faculty. It was called Affectiva, and 2 of my own. All of them could trace their wearable roots back to a very early patent, which was essentially the first wearable washable biosensor, a fabric glove. And in the almost 20 years since then, I've done all kinds of research with biosensor gloves, wristbands, rings, and with different interfaces and form factors. I've produced manufacturing runs in quantities anywhere from 2 to 2,000. I've collaborated with university, corporate, and nonprofit partners who were interested in wearables for various reasons, either to run experiments, to do performances with them, and to create products. I'm not building any of my own products right now, but I do consult, and I am sometimes hired to make product runs, small product runs. And right now I'm consulting and I'm teaching a course at Brandeis in emotion theory, physiology, and effective computing. And we will now turn to Nina Sinatra, who's a PhD candidate at Harvard University.
Good afternoon. Thank you so much, Jocelyn. Glad to be here. So real quick snapshot on myself. I graduated from MIT with my bachelor's in 2012, course 3, and went on to Columbia for my master's also in Mat Sci. I've been here at Harvard for about 4 years in the lab of Professor Kit Parker, the disease biophysics group. And as a material scientist, my specialty fibers-wise is really on nanofibers, and more specifically manufacturing nanofibers and trying to engineer smarts into that manufacturing process. So just as a quick overview, nanofibers are significantly smaller than any of the fibers that are in our clothes right now. So if you think about even just like the sweater that you might have on or athletic apparel, most of that is microfibers. So with nanofibers, by going to a smaller length scale, we are increasing the aspect ratio significantly, which makes them more soft and lightweight. We also have a much higher specific strength, so strength per density. Really, our goal is to engineer tougher fibers, more durable fibers, and functional fibers. The surface area to volume ratio of a nanofiber is also much higher compared to a microfiber. So when we think about building smarts in or functionalizing fibers, that's one technique we can use. So over the past couple of years, the Disease Biophysics Group has developed a few novel ways to manufacture nanofibers that are really enabling us to attack this problem. So previous state-of-the-arts for fiber manufacturing usually revolve around using a strong electric field or a high temperature to extrude nanofibers. This introduces a lot of potential for mismatch in the chemistry of these solutions, also adding a ton of different production parameters that we really think we can sidestep by using more current methods. So our methods for producing nanofibers, probably our most well-known, the rotary jet spinning system, is based on a cotton candy machine. So it's a centrifugal force-based system, and it eludes several of those extra parameters that you would have if you used the electric field. A more current project of mine is a new platform for fiber manufacturing called pull spinning. This is a point and shoot system, so you can think of it just like Spider-Man. The goal here is to make highly aligned fibers at a high rate. So we can use this, or we have been using this for muscle tissue engineering, also for point and shoot clothing. You could think about, shooting a knee brace onto a patient where the fibers align in ways that will support that joint. So these are just some ideas that we've been playing with. And then moving forward, we would like to increase the toughness and durability of these fibers and continue to engineer more function into our manufacturing processes. Thanks so much.
Okay, well, it looks like Jocelyn has patched out, so I'll just step in next and introduce myself. So good morning, everybody. My name is Brad Holschuh. I am currently at the University of Minnesota, but I, previous to this point, was a lifer at MIT. I was class of '07 undergrad in core 16, class of 2010 with a master's, also in core 16, and then finished my PhD in 2014, also AeroAstro, and then postdoced for a year, also AeroAstro. So I spent a lot of time in building 33 and 35, for those of you that are from that part of campus. But now I've joined as an assistant professor here at the University of Minnesota. In my capacity here, I co-direct our wearable technology lab, which is a lab that has existed for about 9 years, was originally founded by my colleague, Professor Lucy Dunn, and we study all aspects of wearable technology. So we think about questions down at the material science level, to the system-wide level, to the human inside the system. Wearables, have become kind of a hot topic in the popular media, which is nice because it brings attention to our work, but I think it's a double-edged sword. It ends up, people are now comfortable with the idea of wearing things, but sometimes they either become complacent with the accuracy, or they become frustrated with the lack of accuracy that some of these systems can provide, which might lead to future mistrust of wearable systems. So a few things that I think would be worth mentioning at this point. I got into wearables through an aerospace vector, as I mentioned, and the transition that made that possible is I was working on spacesuit design. So the lab that I was at MIT is called the Manned Vehicle Lab, and one of their flagship projects is a project called the Biosuit, which is a radical redesign of the spacesuit that operates completely differently from the spacesuits that we've seen for the last 50 years, frankly, ever since we've been sending people to space. It's a mechanical counter pressure suit, which means it's skin tight, and it would replace the giant gas balloon that we currently put astronauts in when we send them to space. It's a really interesting prospect for design, but it's an incredibly different engineering problem. And what I mean by that is it's a compression suit. It's a mechanical compression suit that provides counter pressure on your body through tight-fitting materials rather than pressurized gas, which is a life support necessity when you're in space. In theory, great. Compression garments have been made for decades. It's sort of a well-understood space. The wrinkle that makes designing skin suits for astronauts difficult is the amount of pressure that you have to generate is a third of an atmosphere. 4.5 psi, 225 millimeters of mercury. You can talk about it in any of those units. To give you a comparison, the compression garments that are used in the medical world typically run 20 to 40, sometimes 60 millimeters of mercury. So we're talking anywhere from 5 to 10 times as tight as the commercial grade garments that are out there. And for any of you that have ever worn those garments, you know that that's nearly impossible from an operation standpoint. You could almost never assume it would be possible to put a suit like that on if it were as tight as it needed to be to keep you alive. So, long story short, we went down the path of trying to develop wearable systems that are physically dynamic, that change shape, so that you can have a compression garment that can go from loose fitting to tight fitting on command. And we can get into the details later if people are interested in it, but it launched a research program that I'm now implementing here at Minnesota, looking at dynamic wearable systems. And I mean dynamic in the physical sense. So things that are mechanically responsive to either augment human performance or increase human health, lead to better quality of life for widespread people who are interested in wearable technology. So this is taking what we know about sensing and computing, some of the more mature fields in wearable technology, and adding an element of physical dynamicism to the system. And the ultimate dream is that we'll have clothing that is physically dynamic, that can change shape, that can react either to the user, to the environment, to a remote stimulus, but having wearable systems that can take action to help the wearer is a paradigm that is largely unexplored, in my opinion. And so our lab studies a lot of things. That's my particular expertise, and I'm happy to talk about more of those details if folks are interested later in the telepath.
Sorry, thanks for the heads up. I think I had my microphone muted. So I'm a faculty member here at Harvard. I did my master's and PhD at MIT. I did my master's with Hugh Herr at the MIT Media Lab, and with him I worked on a rigid leg exoskeleton that was funded by DARPA to try and augment soldiers' ability to walk. And with Hugh, we learned firsthand some of the challenges in, interfacing to the body using, big, heavy, rigid exoskeletons. And the challenges were, having the kinematics of the device, match with the kinematics of the wearer, and also, adding significant mass to the wearer really impeded their motion. And I kind of experienced this firsthand as a test subject and walking around the Gordon track at MIT. So after my master's, I did my PhD with Alex Slocum in mechanical engineering. And throughout that, I kind of furthered my expertise in mechanical design, also in robotics and in medical device design, working with a lot of clinicians at the hospitals in Boston. And so after graduating from MIT, I got a faculty position here at Harvard. And when I joined the School of Engineering here, I got some inspiration from other colleagues who were working on this kind of emerging field of soft robotics. So how do you make robots soft using elastomers, textiles, and different types of materials like that, and moving away from traditional types of links and mechanisms and electromechanical motors. So in the lab, we've been kind of working on a bunch of different projects that I would categorize as, generally soft wearable robots. So with these devices, our approach is to think about how do we help people either walk or grasp by giving just small amounts of assistance at the right time to the person. And we're trying to figure out how we do this through platforms, wearable robots that are very lightweight and very non-restrictive. And so to achieve that goal of non-restrictive and lightweight, we've really kind of employed the use of textiles and apparel quite a lot in our research. So we've been developing, systems that help us anchor and attach to the human body so that we can pull, across different joints with cables and apply assistive joint torques. And that's a project that we call our soft exosuit. And so for that project, it started off again as a DARPA project in the DARPA Warrior Web program. And we've, developed technology, tested it at the Army, and showed that we can help healthy people walk with less effort when wearing these devices. But then we've also been thinking about how we can apply that to medical applications too. So our first foray into this area has been to work with stroke patients. And so we've had a lot of stroke patients come into the lab here. We've had a great collaboration with Boston University. And we've been able to show that we can help restore symmetry, reduce energy costs, and improve overall gait for patients who have suffered a stroke with this type of technology. And recently, we also partnered with a company, Rewalk Robotics. So they've licensed the technology and are funding some research here at Harvard, where we're now kind of furthering the device developments to try and get it ready for deployment in the clinic in the next couple of years. So that's more on the lower extremity. That's our soft exosuit project. We're also working in another area of soft wearable robots that's a little bit different, but has a lot of similarities. And with this, we're actually using inflatable soft robots. So a lot of groups in the field of soft robotics have used elastomers or cast elastomers that when you pressurize them with air or water, they can kind of change shape, they can apply forces. So we've been trying to, take that approach and build on it and develop systems that a person can wear that allow them to have assistance when they need it, but not apply restrictions at other times. And so one of the big projects that's on our lab website, if you just Google Harvard Biodesign Lab, is a soft robotic glove. So this is a device that a person would wear who had suffered some type of injury, either spinal cord injury, or maybe they have ALS or have suffered a stroke. And so when wearing this glove, the idea is that when it's pressurized, it can help a person close their hand and grasp objects in a way that they wouldn't maybe not be able to do otherwise. And so the mission here really is, how do we develop assistive devices that people can wear to help perform activities of daily living to allow them to be independent for longer. So there's kind of two projects that we're working on at the moment that leverage a lot of apparel and textiles. I think we're also starting some new efforts looking at consumer applications and other medical applications in this area as well. And I think we've had some great people join the lab who have an expertise in functional apparel design. So they're trained, at an undergrad and maybe a grad level in that area. And those people have been working alongside the mechanical engineers, the electrical engineers, the software engineers in our lab. And we found that to be very fruitful in terms of kind of thinking about what are some new directions we can take to these types of wearable robotic systems that maybe people haven't done before. And in terms of things that I'm excited about in the future, I'm excited about thinking about how do we engage with people who are working more on the material science or manufacturing to really think about how we incorporate more sensors, actuators directly into apparel. And in the future, can we really create truly robotic apparel that you'll eventually be able to wear and it'll assist you in some way, but you can also put it in the washing machine and it'll survive a large number of spin cycles. And I think another area is very much interested in engaging with industry and finding kind of new applications that we can kind of go after in this area. So whether that's, a startup company, that we might want to launch, or whether that's partnering with a larger company and maybe helping to address some of the needs that they've already identified. And so with that, I'll leave it there. I'm happy to answer any questions throughout the panel. Thanks.
Great. Sorry for the technical difficulties. Has everyone done their introduction? Is that where we are? Great. So I guess we have a question from CJ from London, which is, will the great innovations in this space continue to come from the military and NASA, or from non-governmental organizations? I can briefly just add my comment, which is, I think that at least universities and government are working quite closely together, I would say. The different programs that universities can use to get grants from governmental organizations is causing a lot of collaboration. So I think both. And I think there's a lot of innovation coming from industry in the area of wearables. But I'll open it up to anybody who wants to answer.
Yeah, I guess I can speak a little bit to our position here at Minnesota. So we receive a lot of interest from the private sector. Frequently, we have companies that want to interface with us, that come to us asking about trends in the technology development, because I think that we've reached a tipping point now where consumers are comfortable with the concept of wearing technology. The thing that is a stumbling block right now, if we want to talk about this becoming privatized, commercially developed technology, is that people have a limit to how much gadgetry they're willing to tolerate on the body. Some wristbands seem to have achieved some level of consumer tolerance, but the stereotype still persists that wearable technology is going to be something that's grafted onto your shirt, right? You'll have a gadget or a widget that is foreign but attached to you, and it will give you some benefit, but it's different from the clothing that you're wearing. The trends that I see going forward, and the things that I find industry to be most excited about, is the prospect of integrating that technology as part of the clothing in an invisible way. So can we make the sensors, can we make the actuators a piece of the textile at the fiber level in a way that it's invisible from a outsider's perspective, but still give you that technology? So I see when we propose that future, industry partners get extremely excited. But the difficulty is we're not necessarily there yet. I think that academia, government, and industry can all work together to solve some of those problems, but that's the future that will lead to big time industry involvement in wearable technology, because that seems to be what consumers are really asking for. And we're baby stepping into that market, but there's more work to be done.
Great.
Yeah, and this is Conor. I can just chime in on that one as well. I would agree with all of that. And I think, oftentimes with a lot of things, it's, the DoD, DARPA, NASA, some of these government agencies that are funding some of the initial kind of fundamental work that, is highlighting the potential for this space. And I think if you look back over the last 5 to 10 years, there's been a number of different programs from a number of different agencies that have really highlighted the potential for making systems, with integrated electronics and sensors. I think, the DARPA WarioWeb program is another example. NASA has had a bunch of programs related to spacesuits and wearable technology. And so I think I agree that we're at the tipping point, and I think you're starting to see the government launch more applied programs. So the UFO program at MIT is slightly more on the applied side as well, where people are really seeing that, okay, now that we've shown that there's interesting possibilities kind of at a fundamental technology level, I think there's increased focus in terms of, okay, where are the applications? And that's really where you see private industry start to get involved, because they see that, hey, there's been a lot of money invested in this area. The technology is maybe not there, but it's much further along than it was 5 to 10 years ago. How do we start to leverage this for some new interesting applications that wouldn't have been possible otherwise? And so I think it's a very exciting time. And I think for me, I think we also chat to industry a little bit, but I think with industry, I think they're always looking for things that are lower risk. And I think the next kind of 5 years, there's going to be this kind of intermediate kind of period really before industry fully picks up a lot of these things and kind of runs with them kind of more out there concepts of, true kind of sensors and actuators integrated into apparel. And it's a very important time for academia to continue to refine the technology and kind of show proof of concept for some of those applications. And then I see once we see proof of concept, I think that's really where you're going to see a big uptake in industry as well.
Excellent. Did you have a comment, Nina?
I think that pretty much satisfies all of my thoughts. I mean, I think from a consumer perspective, as Brad was saying, most folks now are used to the idea of a Fitbit and getting excited by some of the recent ventures by like Nike and Reebok trying to bring wearables into clothing. But I think as that, idea of self-monitoring kind of is hitting its saturation point, people will move more in the direction of either something with a trainer or a coach incorporated, basically not just sensing output recommendation. And I think that will be more of the direction that the future wearables will be moving towards.
Yeah, I would add that, having worked with so many different trials of form factors on the hand, they're using biosensors. The hand and wrist and fingers is a usual place to get a lot of these signals. But unfortunately, there are some people that would prefer to wear these things on their hand. Some people would prefer to wear them on their wrist. Some people would prefer to have them on their finger. But there really isn't a one solution fits all, because everybody's going to have problems with one thing or another. But everybody has to wear, let's say, a shirt, or you can't go out into regular society. So I think that is what's driving a lot of the desire to have things disappear into these things that we have to wear all the time, because who wants to add an extra piece of jewelry or accessory? I think people glommed onto it because it was the easiest and the first thing. I remember when I went to CES in 2014, I think there were 3,000 different fitness watches from all over the world. It was dizzying. But I believe that's going to fade away as time goes on. I already think that the different kinds of fitness watches are starting to decline because they can't be competitive. So, another question, which I sort of started to answer. This is Seb from Philadelphia. What about sustainability? Do you think of it in any phase of your design? I think of the Samsung watches and the like as just as evil as smartphones.
I could start off with that one. So from a fabric and apparel perspective, the fashion industry between fast fashion and the life cycle of clothes is actually, I think, one of the third or fourth or something like that most polluting industries in the world, right behind paper and cardboard, which might be surprising until you think about, the quick, cheap clothes that might end up in a landfill. And there's a lot of sustainability issues between just discarding clothes and also, shipping. So if you think about, a men's shirt, for example, collared shirt, if it's made in Taiwan and perhaps it has to be shipped to another country to put in like the inset band, to put in some pins, appliques. So now as people are expecting more of these different touches and different types of additions or, to the clothing, that really adds up in practice to a lot of shipping costs and a lot of pollution. So just thinking about sustainability in terms of apparel and recycling clothes, for our research personally, all of the fabrics that we make in our lab are solution-based. So we'll dissolve the material into a very strong organic solvent. So thinking about ways that we can use a process similar to that, or just to bring the life cycle of these clothes back around, or how can we make clothes and fabrics that are easily recyclable, that can easily be incorporated into future garments without having to sort out, the different blends in the yarn, like wool from a polyester, for example. Completing the circle, in other terms. Yeah, so I think that future wearable tech, especially integrating smart function, for example, really has to be cognizant of how to recycle this type of clothes and reintegrate them if possible.
Anyone else?
Another way of looking at sustainability, not from a manufacturing perspective, but from a lifetime use scenario. Conor mentioned this. There's a lot of work that goes into making these gadgets, but there isn't as much work that goes into thinking about, can it survive a wash and dry cycle, right? In our experience, the washing machine is actually not that big of a deal. It's the dryer that causes hell for the components. And if you have, your traditional computer pieces built into a textile, the interconnects between the conductive elements in the textile and this rigid component are the first things to fail, and it's the dryer that kills it. So we absolutely are sensitive to this fact, and it's another reason why pushing the field in the direction of invisible technology, things that are at the fiber level and therefore can be built into clothing without it being a foreign object, is in itself an effort at sustainability, because it increases the lifespan of that technology and that piece of clothing. And it's true that the world of apparel in general is sort of a high offender when we talk about waste production and sustainability. But if wearables want to be included in the conversation as something that can increase in sustainability, that's the approach that I think needs to be taken. And it perfectly dovetails with what the consumers want. So we have really great alignment here with what is good for the environment, good from a sustainability perspective, but also good for consumer preference. Now we just have to start pushing the technology to meet that vision.
What do you think is a typical lifespan for a product with smart fibers at this point, the things you're making?
On our end, we've looked at more traditional electrical engineering approaches, right? If you can make garments with conductive threads all day, that's trivial. You just replace the thread with something that's electrically conductive. We haven't gotten to the point of creating electrical components in fiber form that can mate with those conductive traces. So right now we're limited to this prospect of integrating the rigid pieces onto the textile as a platform. from a life cycle perspective, we do testing into the hundreds up into the low thousands, and we begin to see failure. And I don't want that to sound pessimistic, but it's proof that a different approach is required, right? These things need to end up in a fiber type of form factor. Otherwise, you're going to end up with these failures that happen at the interconnection between the garment and the external foreign piece.
Mm-hmm.
So we're getting there, but it's not a solved problem. It's an active area of research for sure.
Right. Conor, did you want to add something?
Yeah, I guess I would basically agree with all of those comments. I think another approach as well is to think about how do you have things that are very low profile and flexible, and how do you maybe encapsulate them in a way that protects them from some of those harsh environments like a washer or a dryer. But then I think the challenge does always come back down to the interconnects. You know, when you're connecting in whatever sensor you have or actuator you have integrated into the textile, you might have some small box that houses some of your electronics or batteries or other components. But then how do you make sure those two connect all the time in a very robust and repeatable way? And so it kind of sounds like some of this is, they're very practical challenges. You should be able to solve them. But we're talking about, a pretty hard application where you've got lots of different types of materials, lots of different types of manufacturing processes. You want to be able to develop these at scale. You want to be able to make these things low cost, because no one's going to pay $1,000 for a t-shirt, even if it has sensors in it that you wear all day. So I think there's a lot of fundamental material science and manufacturing challenges, and that's not necessarily our lab's expertise, but I think we're very excited to kind of look for how advances in that field can inform more of the full kind of application-driven research that we're focused on in the lab.
There's an interesting question here from Jackie of Boston, who's looking at the supply chain. Who's going to be responsible for building these into wearable products? Is it going to be the clothing manufacturers, or is somebody else going to be building out the wearables part, and the clothing manufacturers are simply going to be adding in sensors from third parties at the end of production? Sort of who's going to be responsible for this? Is it going to be a small startup team? Is it going to be, how's that going to work? I think that's a very interesting question.
Yeah, so I think it comes back down to supply chain, and also the other kind of related point is system integration, right? So if we're building a traditional robot, right, you have some mechanical components, electrical components, you've got a computer, and you've got some software. That's something that we would be able to prototype and build in the lab ourselves, as long as we had people with those different types of expertise. But I think when you get to some of these kind of textile apparel type of applications, it really, I don't think there is yet a very well defined way, one, about how you kind of can very quickly integrate all of those different types of components in a very straightforward way from a prototyping point of view, or from a large scale manufacturing point of view. And I think there's a new advanced manufacturing initiative called NextFlex that was launched, I think, a year or so ago. And I think part of its goal is really to try and think about how do you marry advances in the printed circuit board world and the manufacturing that's used for that, to kind of starting to manufacture more electronics, wiring, etc., that are flexible. And I think that's then a first step in terms of, okay, how do we actually make things at scale that are flexible and have all the types of components that we want? But then I think there remains another hard problem. That's then how do you integrate that into textiles and apparel? And I think it's a very hard problem. I don't think my perspective is I don't think there's an established set way that industry has settled on right now. I know, like, a lot of the big sports and apparel companies, the standard ones that you would think about, a lot of them work with outside vendors when kind of pursuing their wearable projects at the moment. And so I think, to really advance this field, I think you need a really true integrative approach. But the challenge is there's so many different disciplines, and the manufacturing is so complicated that I think there's a lot to do from a systems point of view to figure that out still.
Having done various manufacturing runs, I think you do have to pull from so many different manufacturers. You're using the board company to manufacture your boards, and a clothing manufacturer to do the housing, and then you're having to find ways to integrate them together. And I think there's an enormous amount of entrepreneurial opportunity for anyone that wants to try to solve this problem of marrying all these things in different disciplines together. And I agree, nobody's quite solved it yet, but it's very rich opportunity for someone to solve it. did you have something to say, Nina?
Yeah, absolutely. I mean, I think in terms of, like Brad was saying, integrating components into fibers that will interface with conductive threads, for example. I mean, the fashion industry right now, or apparel manufacturing, if it doesn't fit into their pipeline, it would be really difficult to get those types of components toward more of a consumer base. So I think reducing the number of friction points when designing a system like that, or even just, a nanofiber, novel nanofiber fabric, kind of connecting with the existing systems, at least as a preliminary point, to make a smaller batch run or to work toward a consumer product, will be an important challenge to solve. And there are, I think, a number of issues mechanically with the fibers and in the processing that will go into that.
That's great. Have any of you been involved in startup companies yourselves yet?
Myself.
I have not, no.
I haven't personally been. Some of the work that I did back at MIT, we pursued patents through the TLO office, and I know that there's been a lot of activity on the commercial side and interfacing with those patents. So I've had some exposure with that, but not in a personal entrepreneurial role.
It seems like there's lots of opportunity with these, with the work that you're doing, especially with novel kinds of fibers and invisible sensors in clothing and textiles. Jeevan from Miami says, you hear a lot about second skins. I kind of get creeped out thinking of the safety concerns of putting so many sensors around my heart. How will the industry combat consumer anxieties? Well, a lot of the sensors that you use to measure heart rate aren't actually around your heart. They're on other parts of your body. So I think that particular concern of them being right around your heart, you don't have to be quite as nervous about that. But, I think that it's a natural concern for people that don't, work in the industry and aren't as familiar with all of these sensors and have been putting them on themselves for years to be a little shy of them. I think turning ourselves into cyborgs, as we are doing, is, the general populace really knows about it from science fiction movies of people, wearing suits. I think that can be very unnerving. How do we deal with that?
My colleague Lucy has a famous example that I think is relevant here. She was talking at a conference, and someone asked the question and said, all of these technologies are great, but I just can't imagine having to put these things on every day and take them off every day. That's just exhausting. I don't want to have to think about that. And Lucy looked at her and said, well, you put on clothing every day, right? That everybody now, we've gotten into the habit where you get yourself dressed and you take your clothes off at the end of the day, and we repeat that. So part of the anxiety and the lack of consumer acceptance in this space is because the products that have made it to market are gadgets that are external to what you do. They're different from your routine. It's something else that you have to think about. And the solution in my mind is to, again, make it as invisible as possible. If you wake up and put your shirt on every day, it doesn't feel like you've done anything different, but hey, maybe that shirt has bend and stretch sensors or has a heart rate sensor built into capacitive sensing in the fibers. Then you're getting something for free. You're not asking anybody to change their routine. You're not asking them to keep track of anything else, but it becomes an augmented capability and something that everybody every day already does. And I think that that will go a long way towards reducing the anxiety about compliance, about having to remember things, about feeling like I've become a cyborg because I have stuff grafted to me. It goes a long ways towards either enabling acceptance or producing anxiety if you fail at that task. So I see these as very related problems.
Another issue that I think might come up in there, if you think about, a wearable heart rate sensor, monitoring your vitals over time. I think a lot of consumers right now might be also concerned with data privacy, or who has access to my heart rate or my health. Like, say in the future, these vitals are being sent to a physician or another organization. How do you really reassure the consumer that their medical information, for example, or other information tracking about their day would stay private and that they retain control over that? Just as a parallel in a different industry, if you think about the new home automation devices, such as the Amazon Echo, a lot of people were concerned about, I'm talking to this robot in my house, can it hear me? What is exactly is being transmitted? And I think maybe following a similar approach, just emphasizing that you have control over this device. It's supposed to, like Brad said, be integrated and seamless in your experience during the day, but really just emphasizing that you can control the pathway of whatever this information is and use it the way you would like to, rather than feeling as if someone's eavesdropping or it's going out of your control.
Did you want to add anything else, Conor? Or?
Not to that point, no. I think it was pretty well covered by the other panelists.
So I think it's safe to say that these technologies are in very early stages, and so it's sort of difficult to answer those questions because we're at a stage where they're so early that we're not using them in a way that's seamless at all, and having to put on these sensors that make it very obvious that you're wearing them. It's hard to make comparisons or understand what it would be like to put them on and have them be part of your everyday clothing, and understand that from what we actually have right now, because it's the experience that we're looking towards is very different from what we have now. And I think that's about all the time that we've got today. On behalf of the Alumni Association, I'd like to thank you for tuning in to this Faculty Forum Online Alumni Edition. Thank you to our alumni panelists from Harvard, Brandeis, Central Florida, and Minnesota. I'm sorry we didn't get to all the questions, but rest assured our panelists will see them all later. And you can send any follow-up questions or feedback to alumnilearn@mit.edu. Thanks everyone again for watching, and to my fellow panelists. Bye-bye.
Thanks, everyone. Yep,
Thank
bye.
you.
Thanks again for joining us. For more information on future MIT Alumni Association productions, please visit our website.